Everyone, and welcome to our final session and final day here at 5G Blitz Week presented by Fierce Technology. My name is Alejandro Piñero. I'm the Senior Director for Conference Programming at Fierce Tech, and I'll be your host this morning. Before we get started, I'd like to thank our sponsors for this morning, Sankhya Labs and Quectel, for their support. Right, this morning's session is focused on tackling the 5G design challenge from the chipset to the device, and I would also add really end-to-end through the network as well. Just so you can prepare yourself and know what to expect, here's a brief outline of the agenda. In just a few seconds, we'll have Wayne Lamb. He's the Senior Director of Research Americas for CCS Insight, and he'll be doing a 15-minute keynote on this subject. Following his talk, we'll have Richard Webb, his colleague at CCS Insight. He's a director for network infrastructure, hosting a panel with speakers from Sankhya Labs, Boingo, Transit Wireless, and Quectel. As always, please do submit and send over your questions and comments. You'll see the questions and answers tab on the left side of your screen, and feel free to also use the chat to introduce yourselves, ask any questions to other attendees as well. All right, let's begin now and hand over to Wayne. Wayne, over to you.
Thank you, Alejandro. I hope everybody can hear me all right. Great. So thank you, Fierce Wireless, for inviting me to speak at the keynote today on tackling 5G challenges. Let's take a look. So a quick a background on CCS Insight. CCS Insight is a technology and market intelligence firm headquartered in London. We cover the industry from silicon to subscriber. We work with network operators, hardware manufacturers, semiconductors, and enterprise solution firms to inform and advise. We basically help our clients make sense of the connected world. I myself have over 12 years experience as an industry analyst with background in mobile device design, electronic component, semiconductors, and wireless technologies. I'm currently the director of research for CCS Insight here in the US. And in that capacity, I lead the CCS Insight cost benchmarking service. So with cost benchmarking, we basically are helping our clients uncover intelligence that you otherwise would not be able to. And we do that with competitive analysis. We benchmark cost of devices one to another. We forecast price fluctuations of critical components. And that's how we bring value. And as a result of that research and service, we spend a lot of time looking at 5G devices, their designs, and how they've evolved over the years. So it's my pleasure today to kind of speak on this topic. My colleague Richard Webb will be hosting a panel after this keynote. His coverage area is in network infrastructure. So he'll be talking about the other side of this equation with our esteemed panel of speakers today. So with that, let's get started. So I'm sure there's been a lot of attention paid to 5G networks and infrastructure in this conference this week. However, the UE side, or the device side, is where we're seeing much of the 5G design challenges. So frankly, it's actually a miracle that the 5G phones work with all the connectivity requirements. You have cellular, 5G, 4G, 3G, 2G, Wi-Fi, Bluetooth, ultra wideband, not to mention GPS, and how do you keep them all straight? So not only does the UE have to support all of these, but they're actually the requirements jumped considerably because of all these new radio frequencies coming in, additional RF nuances like massive MIMO and millimeter wave beamforming, all adds to the complication. So the handset represents really the nexus of consumer electronics and telecommunication. And here we're seeing some incredible innovations the last couple of decades. So in this keynote, I want to put one non-trivial example of phone design challenge that has yet to be tackled in 5G. And not surprisingly, it's RF related. So just to give you a scale, each of these blocks are about 10 megahertz. The biggest change in 5G is really access to wider swaths of spectrum. And we can see this is just made for scale. So 4G, there's new spectrum open. The bandwidth got a little wider. You're talking about 20 megahertz blocks, maximum blocks. But in 5G, you can go up to upwards of 400 megahertz. So it's a tremendous amount of increase. Not to mention, most 5G implementations are non-standalone. So you basically have two parallel radio paths with the 4G anchor and the 5G network. So that really just adds to the load that the RF front end has to carry. So beyond that, there's spatial streams that's been spatial stream requirements that's been updated. So 4x4 MIMO was an option in 4G. 5G, it's mandatory in sub-6 networks and sub-6 frequencies. So you can see that there, each individual stream needs a radio path. So that adds to additional challenges, and you can see how this complication builds on itself. And then lastly, not lastly, carrier aggregation is another core principle of LTE and 5G. And that, of course, it builds up to a sort of a exponential growth in complexity for the RF front end. So basically, it's challenging. So smartphones are really a marvel in engineering. Each year they add countless features to the device that is basically limited in size and power. So many innovations had to come together to produce the smartphone that we carry with us today. Arguably the most successful piece of consumer electronics. The smartphone keeps on evolving, and in 5G, the new radio technology ups the ante on signal processing as well as overall compute requirements. Also, it must do so without consuming more power than previous generations, all packaged in a physical limited form factor that's bounded by a lot of design constraints. So no other consumer electronics has been asked to do more with this level of design constraints. And device OEMs have to balance, physical size, computational power, optimizing power consumption. Many of these are contradictory type of limits and requirements. So clearly, beyond doing all the radio paths, you have all these other constraints to deal with. So what does these constraints look like? Let's take a look at the latest Apple iPhone 12. So this is a device that probably represents the most complicated RF front end on the market. This is the US SKU, so it has millimeter wave. So if we take a look at the breakdown, the bill of materials on this device, remember this is just component costs. We're not even talking about cost of goods sold or anything. So if we hone in on the RF front end, it's about $43, which is somewhere north of 13%. Typically, RF front ends as a percentage of bill of materials is about 8% or thereabouts. So there's a significant jump in cost. And so with each, so why is that? So iPhone 12 supports 32 different LTE bands as well as 20 new 5G NR bands. So just as a comparison, when Apple moved from 3G to 4G in 2012 with iPhone 5, it supported only initially five LTE bands, along with a handful of 3G bands that's globally recognized. So the growth over the years has been tremendous. So what does this mean? It means that RF front end has to grow in sophistication and complexity to keep up with all the radio support. These are increases that use RF components like filters, power amplifiers, switches, antenna tuners. In the case of millimeter wave, these new modern antenna in packages, all of which are sourced from only a select group of RF component suppliers like Broadcom, Avago, which part of Broadcom, Skyworks, Qorvo, Murata, and now with Qualcomm. interesting side note, I mean, Apple is always unique in the handset industry in that it's got enough scale where they do a lot of their own RF engineering, and they source from different people. So as opposed to the Android OEMs who tend to take off-the-shelf solutions, whether it's from Qualcomm or MediaTek, and we're beginning to see a lot more adoption of the system-wide modem to antenna packages. So it's very common now to take a look inside a 5G phone with the Qualcomm solution. It also has a Qualcomm RF front end. All right. So with that said, let's take a look at one of these flagship Android devices. So in a 5G RF design in a Galaxy S21. So this is one that kind of represents this notion of a system-wide approach where you have the modem and RF kind of coming from the same vendor. You know that it's kind of like a pre-baked type of a solution. OEMs don't necessarily have to invest as Apple does to fine-tune everything. So the Galaxy S21 leans heavily on using RF modules to really densify and reduce some of the complexity in design and optimize board space. Here we're in the slide, we're seeing a particular front-end module or FEM from Qualcomm, which has been decapsulated. So you can kind of see the inside of that module and all the constituent parts. So there's lots of, you can see that there's lots of these microacoustic filter dies, and each of them have multiple filters. And filters are really critical here because of the fact that they they make for interoperability between different technologies, whether it's cellular, Wi-Fi, what have you. You want to make sure that you don't create interferences. But front-end modules are particularly important in 5G because, as I mentioned earlier, the spatial streams increases. So you have to have four. You can support up to 4 streams coming in on any particular frequency in the sub-6. So the current industry solution has been to use microacoustic filters. Whoops, I jumped. Where was I? Yeah, the current industry solution has been to use microacoustic filters to select the desired section of the spectrum that we need. However, in 5G spectrum, the need to move to a higher frequency. So the only way to get to those wider bandwidths is to move up the frequency range. And, you're talking about 3.5, 4 gigahertz to 5 gigahertz. So all of these open up new challenges for microacoustic filter design because not only is it higher frequency, but also a wider bandwidth. And next here, so I've been talking about phones, but clearly RF complexities also apply to IoT devices. So here we have a Apple Watch, and obviously the size and power constraints are pretty obvious. If we look inside the Apple Watch SE's cellular design, we see that it's much more RF kind of conforms to the design. And what I mean by that is that there's very, very little room for it. Much that the device is made up of the haptic motor and the battery, but the antenna has to be pushed to the glass side or the skin side of the phone. I mean, of the watch, in order to have an effective RF propagation. So it's kind of designing around the product, which is always a challenge. And given that the watch must support VoLTE calling as well as use limited data, Apple had to pack in all the required RF. So it's kind of like a mini smartphone built into a very, very small device. And Apple uses a very dense packaging solution they call system in package. And it's actually quite impressive that we can actually take calls on our risks today. So going back to what I mentioned earlier about microacoustic filter, one of the big holes that currently the industry is seeing is being able to filter these higher bandwidth, higher frequency 5G filters. So as sort of primer on the industry, microacoustic filters, they basically, they take the wireless signal, they transform it into acoustic waveform, and then that helps to filter down into the to the frequencies you desire. So it's a very complex and sophisticated way of filtering. We've seen the advent of a surface acoustic wave, the SAW. That's sort of the first generation, and the second generation is TC SAW, which is temperature compensated surface acoustic wave, and then the latest generation is bulk acoustic wave, and those are really helpful in the mid to high frequencies. But for 5G, that is starting to run out of steam. So they're doing a good job for 4G, but for the requirements of 5G and the sub-6 frequencies and beyond, a more robust filter technology is required. So currently, OEMs are getting away with sort of lesser filter technologies like bandpass because they can't. Because right now it's sort of the Wild West in terms of the spectrum, and it's not that crowded. So the requirements aren't as stringent. However, when 5G evolves and you got all these different spectrums sitting right next to each other, then the RF filtering is much more crucial. So let's take a look at how this industry is addressing it. So one example, I think it makes a very pointed case, is band N79, and band N79 is it butts right up against 5 gigahertz, which is basically the start of Wi-Fi. N79 is primarily used in China, and so if you imagine a smartphone that works on 5G, but then you can't use Wi-Fi, it sort of defeats. I mean, it's a no-starter. So you want to make sure that both wireless connectivity works. So here, a company called Resonant is a sort of an IP company that works on novel filter designs, and their XBAR filter performance has proven through simulation to be relatively effective. So here's an example where the 5G pushes the state of art of microacoustic filters, and you need to create these very sharp cutoffs between the adjacent guardrails, so to speak, of different spectrums. And if you take that further, you think the Wi-Fi 6 and 6E that goes into the 6 gigahertz. It's actually the higher upper end of Wi-Fi 6E goes to 7.1 gigahertz or so, and that is basically right up next to ultra wideband. So these are the new connectivities that we're seeing coming into smartphones. Things that enable you to use your Apple AirTags and so forth, and that's also coming into play. So you got to play nice with ultra wideband now. So all of these spectrums are going to be fully utilized, and therefore a technology that's needed to really make sure everything works and nobody steps on each other in terms of using the spectrum. So what are the takeaways from this keynote? So 5G is constantly evolving. We've currently are in 3GPP release 15 level version of 5G. We're moving to 16. There's going to be a lot more complexities and a lot more demands on RF, and that's going to be a challenge moving forward for OEMs, components, suppliers, and not only to address it, but but not to do it in a sustainable manner where, the RF front end doesn't go up in cost and kind of eat up the bill of materials. The RF filter remains the biggest concern moving forward. And I think you see an example of innovation in the industry trying to come to meet this demand. Resonant XBAR filters an example of that. The mobile industry is also witnessing an unprecedented consolidation, in OEM brands and so forth, as well as semiconductor component suppliers. So we mentioned the big five that dominate the space. On the device side, Samsung and Apple continue to consolidate their leadership. They're both working on their own SoCs. Samsung has their own modem solution. Apple is sort of on the cusp of getting their own modem solution through the Intel acquisition. So these ever-changing market dynamics will hopefully lead to conditions to solve some of these challenges moving forward in 5G, because you really need scale and ability to do and invest in R&D to solve these problems. And lastly, with any consumer device, the design challenge is always present. It's really how well you manage them and what trade-offs you make. This talk's really focused on RF front end of smartphones, but I hope overall the message you take away is that 5G challenges exist. They're not, it isn't guaranteed everything is going to work fine. So the industry has to be very focused on tackling those challenges. So with that, thank you very much. These slides are available as PDFs with download. So if you have any follow-up questions or anything like that, my email is on the front cover. So thank you very much. I'll pass along.
Thank you, Wayne. What a fascinating presentation. Thank you so much. All right, we're going to head over now to our final panel. It'll be hosted by Richard Webb. He's Director for Network Infrastructure at CCS Insight, and he'll be joined by speakers from Sankya Labs, Boingo Wireless, Transit Wireless, and Quectel. Please remember to send your questions to the questions and answers tab, and send your comments through as well. All right, Richard, over to you now for our panel.
Thank you very much, Alejandro, and welcome. Thank you, Wayne, also for that lead-in presentation. So we've got a panel of experts. We've got an incredibly broad but fascinating topic to discuss this afternoon. Before we pitch into it, I'm going to go round our virtual roundtable and just ask each of our contributors to introduce themselves, say a little bit about their job title and their focus area. So we'll go alphabetically by company, so that would make it Boingo to start. So Derek.
All right. Hello, everyone. I'm Derek Peterson. I'm the CTO for Boingo Wireless. As most of you know, we operate networks around the globe, DAS, small cells, 5G, and Wi-Fi. And a lot of people know us for the Wi-Fi, but just as important are all those other systems that we're doing. And we're here to talk about 5G, and I'll be sharing my thoughts on the converged approach. Thanks for having me.
Welcome, Derek. And on to Jonathan.
Hi, this is Jonathan. I'm Quectel's high-speed product manager, dedicated cover for the IoT Advanced and the 5G modules. And I'm also in charge of our company's 5G development teams. So thanks for having me.
Thank you very much, Jonathan. Welcome. And Parag, over to you. Parag, you might be on mute.
Oh, sorry. Can you hear me now?
Yes, we can. Go ahead.
Okay.
Go ahead.
Yeah, so I'm the co-founder and CEO at Sankya Labs. We build ORAN-based, semiconductors, hardware and software for the 5G infrastructure side. We specialize in software-defined radios, which is basically software-defined networking for layer 1. I look forward to talking to you all.
Okay, thank you, Parag. And Jyoti.
Hi, I'm Jyoti Mahurkar-Thombre. I'm the CTO of Transit Wireless. I lead the engineering and operations team, and we bring communication networks to rail passengers at stations, platforms, trains, and through tunnels. So we operate DAS, Wi-Fi, small cell technologies, and I'm really pleased to be here today to talk about how we can tackle the 5G design challenge.
Thank you very much. Welcome, everyone. So, as my colleague Wayne was saying, 5G, incredibly complicated platform. It's really nothing like the step change in mobile that we've had through 2G, 3G, 4G. Really, 5G is kind of an umbrella term for a suite of technologies or platforms, if you like. So, let's pitch into that. What does it mean in terms of an ecosystem of solutions across an increasingly broad series of different use cases, all of which seem to have increasingly tough requirements in terms of performance? It's getting tougher and tougher, isn't it? So, let's start with R&D. What does the industry need to get right from an R&D perspective in terms of that end-to-end 5G ecosystem of solutions to ensure seamless, fast connectivity, not just for now, but for the use cases that perhaps we haven't even dreamed of yet. Anyone want to come in with some fairly general, holistic comments to kick us off? What's the industry got to do here?
Sure,
Go
I'll
ahead,
start. Oh, sorry. I'll go ahead and start. I think one of the challenges that you saw in the presentation is we still put all of these coexisting technologies in a phone instead of recognizing that they need to co-integrate. And that's really, to me, the challenge that we're under right now. When you think about the evolution of computers and software and everything that's been going on in the last 20 years, when we started off, we were programming in C all the way down to the chip level. And then we ended up introducing Java in 1991, and we started going, oh, well, let's put it in an engine that runs. And we're still in the networking side. We're still on that mode where we're programming down to that file layer and the chip layer sometimes. And we're trying to make those things coexist instead of those things co-integrate together. And that's where we need to change our mindset and start saying, okay, how do we think about co-integration? Because convergence of all of these technologies isn't going to happen without co-integration.
Good point. Jyoti, you wanted to come in?
Yes. So, 5G is much more about the objects that it's going to operate on. So unlike the previous wireless technologies, 5G looks to make every object self-aware. And that involves collecting data, correlating it, doing analytics on it, machine learning, and actually solving business problems like we've never done before. So for me, one of the biggest things that the industry has to prove is we have to start experiencing what the ultra-fast, low-latency network that's highly reliable feels like. Unlike the other generations before it, very sensitive and mission-critical applications are moving to the network. And this makes network reliability and security even more paramount than it was in 4G and 3G. Because if we're going to be having autonomous cars, autonomous trains, and our surgeons are going to be operating on us from miles and miles away, I don't know about you, but that network reliability has to approach 6 nines.
Absolutely. Yeah, and I still think the industry, certainly at the consumer-facing part, considers 5G as a mobile phone network, whereas really it's far from that. It's only one of the many, many things it can do. So you're right, I think, and Derek, about that mindset shift. Parag, did you want to come in? Yeah, go ahead.
Yeah, so if you look at the entire ecosystem on the consumer side, Wayne laid out the lay of the land, and there you got from a device perspective, it's all about integration, right? You want to pack in as many functionalities into the device, and also, like Derek said, talk about convergence on the side of the device. But on the infrastructure side, it's just the opposite. You want to you are going away from, I mean, an inside out view of 5G would be that you're going away from a traditional appliance based network to more cloud network where there's a lot of fiber available. And there, it's not about integration, where in the erstwhile base stations in 4G and 3G you had all the functionality inside a single chip, but it's more disaggregation, right? You want to do specialized functions for specialized functionality. And that's where a new class of architectures in the semiconductors is spawning out. We call that the domain-specific architectures. And I completely agree with Derek on the fact that we've been programming devices pretty much the same in the last 35, 40 years. So the entire the entire cloud industry, from an application perspective, moved up 2 levels of abstraction, right, from Java to now Python to Go and other languages. Whereas in the layer one, we've just started to move away from FPGAs and custom ASICs to more software solutions. And when you do that, they're still very closely tied to the hardware. So your productivity rates are much lower when you start to do this. So I've got a corollary to Moore's law, which says that every 5 years you should have a jump in abstraction, and that's when the productivity improves. And and consortia like Open RAN and Openness help you go towards that. Because they allow a whole lot of other people, large players, a large set of smaller and diverse players to come in and contribute to the overall ecosystem.
Yeah, absolutely. Thanks, Parag. Yeah, I think it's really important that we put those networks in context of that shift towards a computing-based platform, cloud-native, software-driven, virtualized functionality. We're definitely going to get into that in a lot more detail. But before I go on to my next question, Jonathan, did you want to make any opening comments?
Yes. Yes. 5G is really a challenge to our wireless industry, since compared to the LTE, 5G not enhanced on the wireless connections, including the throughput, low latencies, but also 5G just want to totally transfer the ecosystem from 4G. From current 4G on this ecosystem, the carriers just like the data carrier. It cannot make a lot of money from the data transmission. A lot of money is made by the SAP, the service providers, just like Google, like Amazon, like Facebook. They make these things, since they can get the value from the data transmitted on the wireless. But but for the carriers, what they can, the revenue just come from carry 1 bit or 1 byte, these kind of things. But a lot of value inside the data, carrier cannot have any way to get the profit from it. But in 5G, the total revolution is that the carriers want to touch this value or this revenue from the data. So 5G introduced network slicing, introduce the NFV, introduce the software design network. All these things just enable the carriers to implement their platform and their services, make their services more easy to implement in the 5G systems. And then for the carriers, they can transfer another Facebook, transfer to another Google companies. Maybe they can some subsidiaries companies can do this work. Then they can make money, and the cut profit come to the SAP, the Google and the Facebook, these companies. So this was, I think, these ambitions from the carrier they want to do in the 5G areas. And also 5G not, as we know, 5G not connect to people. People connect people. Yeah, please. Sorry.
That's right, and that's a good point. We mustn't forget that there's going to be a revenue stream. Sorry, go ahead, Jonathan.
Yeah, and 5G, the main target is connect to machine to machine. There's a lot of millions or billions of the machines in the world need 5G to connect. And also it can be driven more applications like the automate drive, like a drone, like AI, these kind of systems when machine and machine connected, a lot of things and this ecosystem can be built diversified, much diversified than current LTE network can do. So this is I think is a mysterious and wonderful things 5G will bring to us.
Yeah, it's a good point, and absolutely you're right
But the
to
challenge is,
bring in
yes,
the operator perspective, because there's a lot of onus on operators with 5G spectrum to deliver this wonderful new future for us. But what does the industry need to do in terms of helping them, providing that ecosystem of solutions? Let's look a little bit about R&D cycles, how we help operators by putting economies of scale in place and things like that, and maybe kind of those performance metrics that these new use cases are going to require. How do we tackle that? I want to jump in on that. What does it mean for design? Go ahead, Jyoti.
I think what's going to be important is for industries to take a good look at what are the building blocks and how do they reimagine themselves. So if you wake up one day and all of a sudden an ultra fast, low latency, high reliability network was somehow available to you, what could you do with that? And I think here we have to resist the temptation to do everything ourselves. So for example, 5G enables high resolution cameras and the transmittal of all those images in a very, very fast manner. So a company that is looking to do security, they don't need to reinvent the camera because the cameras exist. What they need to do is figure out how do they take that camera, what is the secret sauce they bring to the equation, and they need to build their application around existing components. And if you do that, you achieve a fast time to market as well as economies of scale because everyone is not building everything from scratch. Similarly, in the rail industry, there's a desire to use drones to do inspection of tracks. Some companies are already starting to do that. So rail companies they don't need to invent the drone. They do need to figure out how to teach the drone what to look for and what images and what data to capture. So that's their secret sauce. So I think it's very important before a vertical or a company sets out to integrate 5G into their operation, that they figure out what is the best way for them to innovate and how to rely on others who've already built the building blocks.
Good point. Anyone want to pick up on that?
Yeah, I'll go ahead and go. I mean, I agree. I think one of the key things is we've been talking about in the past. Okay, the job of the network operator is to deliver bits, and I think that is an important part of what we do, but it's not why we do it. And the reason why we deliver bits is because we're trying to solve use cases, deliver experiences, and help venues and locations with their vision of how they want to improve operations and all of those things that were shared. So that's the change that's happening. And so what we need to recognize is that for that change to occur, and as I'll point, in my little sign back here, it really requires collaboration as shared. So we need to collaborate together across industries, across these different technologies, and put them together. Again, it's about that collaboration is the key part. And those partnerships in 5G are going to be essential. So when you talk R&D and you say, how is the R&D cycle changing and what is the change happening in the R&D cycle? The change is instead of you having a single R&D location and a single company doing the R&D, you're now having multiple companies coming together. And the examples that we're given are pretty good examples. You have the camera manufacturer, the data guys, the connectivity layer. You have all of these different layers that are trying to put together, and they need to collaborate together. I mean, I look at it the way we think of security is another good example. we end up putting in security to each level of the OSI model, and then we don't end up having that security go all the way through. So you have an application security, and then you go create an IPsec tunnel, and then you go create all these different layers, but you don't recognize that, well, I'm not going to be secure unless I'm secure all the way down the stack. And this part of the stack has no idea what this part of the stack's doing. And that's where that becomes very important for us to think about, is that collaboration through that is just as important as the collaboration with each other. And then we're going to build these use cases and experiences and create the vision that we want of the future of what 5G is. And what that is all those great experiences available to us.
Yeah, good point. Anyone want to kind of pick up on that?
Yeah, Richard.
Yeah. Go ahead, Parag.
To add to both of them, the collaboration is very important, and I think it's pretty diverse. Like Derek said, I mean, you've got security as one aspect, you've got AI/ML, you've got semiconductors, you've got signal processing. So if you just take the radio access network, right, and the baby steps that we have taken towards Open RAN and ORAN, you already have some kind of collaboration. There are new partnerships coming up, the system integrators coming up, and even in something like just building a layer one, you've got an ecosystem there. You've got a semiconductor player, you've got a hardware manufacturer, a part server manufacturer, an accelerator card manufacturer, you've got a software player, and all of these have to come together, right? And then I think that's the whole concept of being vertically integrated, where one single vendor provided everything in a network is going away to an ecosystem. Of course, with that there are a lot of challenges in terms of how do you interoperate and how do you get diverse teams to collaborate. But I think there are parallels in the industry. We should look no further than say the Linux model. When Linux first opened up in the 90s, when Unix was closed, it unleashed a whole lot of innovation, and then you had developers all around the world contributing. And we have many millions of people, not millions, well, in this case, probably a few thousands instead of a few hundreds or a few tens of thousands looking at code, schematics, looking at security aspects. Things become more robust, more resilient, and more secure. And I think that's the way we should be going forward.
Interesting. Jonathan, did you want to come in?
Open model, one last point, sorry, Richard. The open model is not so prevalent in the hardware industry. I think we're catching up there. I think once the hardware also starts to become open with a lot of open interfaces, you could get a diverse ecosystem of players to build solutions for customers.
Okay, thanks, Parag. Good point. I'm going to pick up on that notion of openness in just a minute, but I wanted to give Jonathan a chance to come in. Jonathan, I think you might be on mute.
Oh, sorry, I'm mute. Yeah, I agree with Derek said that this 5G devices design is a very complex thing. The 5G currently still keep on the evolution from the release 3GP release 15, currently release 16, and then come to release 17. So with the evolution, and our customers must want the product can be also evolutable. So I think the collaboration must be needed, since some companies is just mainly focus on the wireless side. Like a Quectel, we provide the modules and 5G modules. We provide a customer with wireless access. They enable our customer for the 5G wireless connections. And our customers maybe just focus on some main applications for 5G, like camera, like a drone, and maybe like an autumn drive car. So every companies have put their lot of resources on the industrial side, which they're familiar, and that can be contributed to a wonderful product. And then all these companies work together, then can bring a wonderful 5G devices. And these devices also, this collaboration not only by the hardware side, also by the software side. the hardware side, like Quectel, we provide the wireless connection. So mainly working on the baseband, working with on the RF part, with the antenna side, these kind of things. And also our customer mainly working on the application, like bring more higher resolution video or cameras, or faster moving, more fast cars, these kind of things. And for software applications, like we provided the detail, like we provided the basic transmission layer, physical layer, or MAC layer, this kind of the applications. But for high data transmission, for example, how to guarantee the security, how to guarantee the QoS of the data, and how to comply working with the base station side, network side, to provide a network slicing services. So the software also have different layer, which can be either provided by different product or different companies. So they will be involved a lot of collaboration, in my opinion, from now to future. This will be along the whole 5G period.
Okay, thank you, Jonathan. I'm going to pick up on that. But first of all, I just want to remind our audience that you can submit live questions to our panel. Just use the Q&A part of the webinar interface. Type your questions in, and we will be keeping an eye on any questions coming in. Okay, so we've introduced this idea of open source, open networks, open interfaces. But at 5G, this is risky business. At this expensive spectrum we're building networks with, we can't afford to just sort of open our networks to anyone who wants to sell us pieces of solutions. Isn't it much easier to just build it using one solution provider, end-to-end, tightly integrated, going with a trusted supplier who's been doing it for decades? Why wouldn't we do that? Anyone want to come and shoot me down?
I think we already all have, but I'll just say, one of the things we look at in the history of computers, right? When we open it up, we end up adding that abstraction that was talked about. We end up adding some more innovation. One of the things I'd say is, we're in a unique time right now, and there's a question that I saw, which is, what application will be the main driver for 5G? The approach that you say, where we're going to end up having a single solution, they're going to build something for a single application. That's not what we want. We wanted 5G to be an opportunity for changing experiences. So I'd change that question that was asked, and I'd say, what kind of experiences are we going to create with 5G that's going to be the main driver? And then I would say, given what's going on with COVID, and we think it's going to go away, it might not. We're working from home. The way our worlds are changing, the way we're trying to do touchless payments, touchless ticketing, all these different things we're going to do. The experiences we're going to try to create is a safe, secure, simple, seamless experiences by taking advantage of technology. And 5G gives us that, right? So we're going to end up having these kind of new experiences where we can end up walking into a gate without having to have a piece of paper and somebody scan it, or make a payment without having to sit there and hand a card back and forth and have that kind of experience happening there, which is going to end up creating new opportunities for us. And the digital transformation, being able to carry bits faster, and all this stuff that we've been talking about enables that. And so it's really about that. And you get there by recognizing that there's new experiences you want across the industry, and creating it by having openness to do so.
Okay, yeah, and I absolutely apologize for the way I phrased that question. Let's put it a different way then. If we take openness, we want a varied, open solutions ecosystem, software, hardware, devices. If we, for example, are going to build upon the concept of open RAN within 5G networks, what do we still need in terms of standards, in terms of understandings and learnings that we can build from? Because we're not just talking about a technological landscape, but we're talking about a commercial landscape as well. Anyone want to kind of talk a little bit more about what we need to do to really drive openness through? We take it on board as a concept, yes. it's still got some challenges before it's reached that acceptance level with operators.
So I think one of the things that makes openness a reality is interoperability. And when you think about the plethora of devices and network components and the different firmware software releases, the combinations that you could end up with is actually enough to give CIOs and CTOs a headache. So I think we have to have a different way that we do interoperability and testing of our solutions, because remember how I said that reliability of the network and the overall service is what's going to be measured. So you can't come in with a new release of some network element that then starts to cause network outages or, to Derek's point, creates security vulnerabilities. So I think it's very promising that several of the standards bodies are recognizing how important interoperability is. And instead of leaving the standards and the interoperability as an exercise for the industry, they're actually starting to define what that means. There are companies that are starting to almost sell interoperability as a service. So if you need A, B, and C integrated, these companies actually will build that capability and they will make sure that interoperability exists. So you really can't have openness without interoperability that is ironclad.
Good point. Thank you.
Yeah,
Go ahead, Pat.
I completely agree. Sorry. Yeah, I agree with Jyoti, and I would take one step further and say interoperability and also frameworks, right? And building on top of existing frameworks. I mean, starting from scratch is not really an option. And that's how, and I think we should look no further than two parallels in the computing industry. I think one is compilers. I think late 80s and early 90s, you had all these compiler companies that actually sold compilers. And eventually, the open source GNU compiler thing came in, and it kind of, I wouldn't say killed it, but it became more open. And then because of the framework that GCC created, you had all the innovations that have come into compiler, and then that's made programming and productivity gains that we've made over. And the second one is Linux itself, right? And operating system is a pretty complex piece of code, and everybody had the same issues that you're talking about right now. How do we trust an open and a new set of ecosystem vendors to deliver only about a bunch of trusted ones? But over a period of time, the benefits kind of override the disadvantages that come in. Of course, there are going to be teething problems, but that we can overcome through through all these consortia and like Jyoti talked about, interoperability suites and frameworks. We should get over that.
Okay, thank you, Parag. Okay, we've got a few minutes left. I'm going to jump to a couple of questions coming in from our audience. The first one is around IoT within 5G. Anyone's got any thoughts on design for IoT, where we're at, what we need to be doing to make it connect and interoperate better with 5G?
I mean, I think we all could.
Go ahead, Derek, and then I'll come to Jonathan after Derek.
Yeah, all right, I'll be quick. I think that the key thing is for interoperability to happen, you need to be able to have these things connect, which is also very important, right? There's lots of different IoT devices on a lot of different technologies. And more importantly than ever is once you get an IoT device connected, it's about that experience that you're trying to have with it. So I always say, IoT needs to be moved towards IOMe, right? So it's not about the internet of the thing, it's about the internet of my experience. So IOMe. And that's really what we need to create with these things is that internet of my experience. That's how we get it to make them collaborate and work together and be able to deliver that for what we want. And I'll let you chime in now quickly.
Go ahead, Jonathan.
Okay, so IoT I think is also a very, very important thing in 5G. And 5G is, according to 5G, their mission is just dedicated for connect to machines. So it's Internet of Things. But currently IoT for IoT also have for current standard also have NB-IoT or IoT Cat-M. This is also provide a low data transmission for the devices like meters, water meters, or electrical meters. They don't need the high throughput. They just have some very few byte to transmit. So this continue. But also 5G, according to the 3G standard, they will also take the current exist IoT standard into 5G standard. That means it's called frequency frequent involved. So that means the IoT device is currently working on already deployed IoT devices can be worked in 5G areas as well. So 5G will cover the older IoT devices. So the customer though don't worry about these things. And also besides to be coexisted with the current IoTs, 5G also provided the massive IoT connection capabilities. So it's mainly based on like the data center, like network slicing or network like the NFV. This kind of the architectures make the network site easy to expand its capacity to have massive or millions of IoT devices to connect to this network. And this is an IoT devices and can also interwork with 4G or 3G devices. So the 5G is not cut off all the old system at first. At the first 5G first stage, the 5G must inherit the old system to let them all the old system working well together. But maybe for the 3GP standard evolution and the new technology will introduced and maybe will be replaced. But it's a long time, in my opinion.
Okay, thank you very much. Okay, we've probably just got enough time to make some concluding comments. I'm going to wrap it round one of the questions we've got coming in around 6G. So I'm going to go around and ask everyone to give a little impression to leave us with about what you're expecting to see in the next few phases of 5G into 6G. I'll start with you, Jyoti. What are you expecting to see over the next few years, 5G to 6G?
I think once 5G matures, we're going to really be able to tackle some of the important problems that the earlier generations haven't been able to, such as making the device and making the service affordable so that we can finally make a dent in the digital divide. I think the pandemic revealed to us, even in so-called developed nations, that the digital divide is very real. I think 6G, one of the primary focus, I hope, is in using data analytics to make networks more energy efficient and sustainable. Because we know today that there's a Pareto, right? That 10% of the network cell sites are carrying more than 50% of the traffic. And so we ought to, by the time 6G rolls around, use information like that and make network sustainability a reality.
Very good points indeed. Yeah. Thank you, Jyoti. All right, go ahead.
Yeah, so I think there are two views of 6G. One is it's faster 5G with large swaths of spectrum. The other view I have is basically that networks become more cognitive and networks become far more intelligent. They can, to an extent that they start to design themselves, right? Today, networks, even in 5G, are designed for worst-case scenarios. You have the signaling, which is for assuming that everybody is going at 500 kilometers per hour, everybody sees a bad channel, and so on and so forth. The network itself is very dynamic. The inherent pattern of any wireless network is that it changes every few milliseconds, and to adapt to that pattern, right, you would have the network design itself. I would go to an extent saying that potentially 6G could be a solution where a bot in the cloud designs the network, right, or designs a wireless standard. You don't need a 3GPP, hopefully going from 6G to 7G and so on and so forth. It would be designed by itself based on all the inputs it gets from the from its environment.
Okay, thank you very much, Parag. Jonathan, any concluding comments around 5G to 6G, and then we'll close with Derek.
Okay. I think it may be some earlier to talk about 6G, since currently 5G is still on the early age, and I think the main challenger for 5G to 6G is how 5G can build up the revolution ecosystem on of it, and if 5G cannot make a lot of revenue from the business, maybe for 6G will be much far from us. But currently, I think since 5G will introduce mainly focus on the internet connecting machine to machines, we just also I'm also optimistic about with a lot of new application come in, and then the 5G will show its advantage than current 4G, which can provide to this new application things, and then the carrier can make revenue from these applications. Then they may consider to move to 6G. And also, I think in 5G areas, carriers must to also need to have a revolution from their current 4G situations. Since in 4G they just working as a work very hard, but cannot make a lot of money. In 5G area, they must build up this ecosystem and make their carrier 5G platform can be with value added and also with flexible. This kind of things be built up, and then we may be easy for carriers transfer from 5G to 6G. So I think this time will take at maybe 5 to 8 years at least.
Okay. Thanks very much, Jonathan. Derek, wrap us up.
So, I think one of the things we've been talking about is there's a lot of things happening, right? So we're moving towards infrastructure was purposely built to a borderless infrastructure. We're moving from programs that had to be built to sentient programming, where we're going to end up having programs program themselves as was shared. And we're moving from AI and ML to manage tolerance in our networks to a quantum tolerance where it works, right? And to me, that's the biggest change. When we think quantum, we're thinking things are changing. This idea that we need to have 5 nines and we need to have a program confined in this little spot, and instead of it be a container or a microservice that can move around in our borderless infrastructure, and then the security behind it. What quantum's going to bring for us is this opportunity to build tolerance throughout the applications, throughout the networks, throughout all this connectivity, and be able to have this quantum tolerant sentient object running container, if we want to use those current terms, to be able to create this experiences that we want. And so 5G, some people say, all right, well, so 5G is about making things faster and improving all these things. What it's really about, it's about creating a micro environment and a platform on frameworks to be able to then get into 6G, where we really take off with all these new experiences, because we built the foundations in 5G to do that, because we now have the more bandwidth and the more megahertz and the open RAN and the open programming languages, so that we can now then, take that next jump. And I really believe that 5G is like an introduction to really that next quantum level. And that's why we're calling it quantum, because it is a quantum jump. And I think it's going to be exciting.
Absolutely. What a perfect point to draw a conclusion to our panel. Thank you very much, Derek. But also thank you, Parag, Jyoti, and Jonathan, and everyone in the audience for joining us. I'm going to hand back to Alejandro. Thank you very much for your time. Thank you.
Thank you. Thank you, Richard. Pleasure.
Great. Thank you so much, Richard, and to our panelists for a fascinating discussion, and to all of you for sending over so many questions. Well, that actually brings to a close our 5G Blitz Week. And from Fierce Technology, I want to give a special thank you to our sponsors for this session, Sankya Labs and Quectel, for their support. More widely, of course, to all of our speakers and sponsors, as well as the attendees who've joined us all week for a very successful and exciting event. Thank you all for your support. Well, that's it from us. So thank you again, and stay safe out there, and see you soon.